What we're going to be going over here is the incremental unit time learning model versus the cumulative average time learning model. And we're going to make a comparison between these two different models. We'll first lay these two different models out here on an Excel spreadsheet, or an Excel calculator as I might call it, and then we'll make the comparison or graphical comparison by comparing these two different learning models. And we'll lay out the different Excel functions here on those graphs as well here. Okay, so the first thing we're going to start with is our learning curve calculator. That would be our Excel calculator. So when you're working with these learning curves, you're going to have to first determine a learning rate here, and then based on your learning rate, you have an improvement rate here. So those have to add up to 100%. We'll be looking at a 80% learning rate here. So based on an 80% learning rate, we're going to have in a 20% improvement rate. So what we're saying here with our learning curve is every time we double our production, we're going to decrease our average time or our unit time or our total time here to produce the product by 20%. So if we were talking about a 90% learning rate, we would have a 10% improvement rate. And by doing that, if you double your production, then you'd only be reducing your unit time here by 10% with a 90% learning rate. Okay, so that's how that functions. Okay, so the first thing we're going to be looking at here with our Excel calculator, really you have 4 different columns you have to deal with. You're going to have our A column here is going to be our number of units that we're producing. Then our B column here is going to be a function that we set up. This is going to be our learning curve here, a function learning curve, and that's going to be shared common between both our cumulative and our incremental model here. And then we're going to have a column C, and this is going to be our total time here. And we're going to be starting with the cumulative model here, and then we'll look at the compare it to the incremental model here. So C is really what we're getting down to when we're dealing with these learning rates. We have to determine our total cost here based on our learning curve. And then column D here just is going to be for comparison purposes, just the individual unit time here based on our learning curve here. Okay, so the first thing we have here, of course we have our units here, 1 through whatever. 1, 2, 3, 4, 5, 6. That's our units or the quantity that we're producing here. And those could be in lot numbers and so forth here. But what's common between these two different models here, the cumulative model and the incremental model, is this unit cost here. This is what we have to, that function we're going to be looking at, f of x here. So we're going to start with a unit cost here in our learning model. We'll just start with 100 or 100 hours here. But what is this f of x function here? What that is y here. That's going to be either our average unit time or our total unit time. Once we times our quantity here, that's going to equal a, which is the cost of the first unit here. I'm showing that in green, times x. That's whatever unit quantity or numbers a unit number we're dealing with, and that's raised to our learning rate here, b. Okay, so let's go look at that. That b exponent here is what makes this learning curve here an exponential curve here. Okay, so let's go and look at it up here. Okay, so first off, b, that's our learning rate here, and that equals the log of base 2 to whatever the learning rate is. And we're dealing with an 80% learning rate here, so it's be 0.80 here. So a log of base 2 of 0.80 is going to give us a negative 0.322 here. And that's the learning rate we're going to be dealing with here. Okay, so that's our learning rate here. So let's just look at our general function, our f of x function that we're dealing with in column B here. That's really our unit time here. Y, that's going to be our unit time. That's going to equal a, again, the cost of the first unit, times whatever x, whatever number of units we're working with here, raised to b, our learning rate here. Okay, so now we get down to our total time here. And that total time is just taking x, quantity of units we're working with here, times y, our unit time here, and that's going to equal x raised to the power of 1 times a here times x raised to our learning rate b here. So you can just take the algebra here, and then that total time here by combining our terms here, x times y, that equals a, the cost of the first unit here, x units we're working with, raised to the power of 1 plus b, just through our algebra here. And then this x here, that pertains to the cumulative time. With cumulative time, your number of units relates directly to your formula here, that x. that we're raising to 1 plus b here. But for the incremental model, you have to go through some special calculations, and that's going to be some k value here. But just to make the point here, with the cumulative amount, this x and this k, they are not directly related here. They are different numbers. With the cumulative model, you're working with the actual units that you're producing here or looking at the time. With the incremental model, you have to go through some special calculations to come up with that. And incidentally, I do have videos out detailing both of these different methods here, both with the Excel spreadsheet and other comparisons. Okay, so let's go down and let's look at our cumulative model here. So we got our formula set up. Again, A, these are the number of units we're producing, 1 through whatever here. And then that unit cost, that f of x, that was our function here. And then that's for B, column B, and then column C here. That is really that total time that we're looking at. And this is really the key to the difference between the incremental and the cumulative average models here for our different times here. And then D here, that's just looking at some individual unit time based on our cumulative time here and our different quantities here. So for our cumulative model here, of course, that f of x, I'm showing that here. We would start out with a unit time of 100, and then using our learning rate here of 80%, or our b, our power here, b, that we're exponent b that we're raising it to. Our next, for our second unit, would come down to 80, third unit 70.2, and so forth here. But the key is this cumulative total time that we're looking at. For our cumulative model, all we're doing is taking our A column here, whatever quantity we have in our A column, times whatever our unit cost here would be in our B column. So A here, looking at, say, 2 here, our output of 2 here, units of 2, times our learning rate here, our unit cost here, 0.80 here, or 80 hours, you could look at it, that's going to equal 160, and so forth. 3 times 70 here is going to give you 210, and so on here. Okay, so that's really our cumulative total time that we're dealing with. And this is the key figure that we're looking at, column C here, between these two different models here. And then the individual unit time, that's simply taking, in the case here of our cumulative time, that's just taking, let's look at it, C6 here, that would be like a 160 hours we have here for total time versus what we had here the previous time, 100. So that difference, C6 versus C5, or difference between our differences in between our different quantities we're dealing with here, that difference is going to equal our individual time. So 160 here less 100 gives us 60 here for our individual time here. And then looking at the next number, just taking 210 here less 160 to be C7 here versus C6, we get down to 50, and so on. That's how it works here. Okay, so that's for our cumulative model here. Now let's go down and let's look at our incremental model here. Okay, same situation. What is comparing between the learning curve calculators here for both the cumulative and the incremental? Of course, you have your units. Those would be the same here. And then that f of x, that function you're dealing with, that learning rate function here, we have come up with the same quantities here between the two different models here. But what does change is this cumulative total cost that we're looking at here. So with the incremental model, all we're doing is we're taking our f of x function here, our unit cost, and we're just summing it for we're just summing the totals. So if we look at our sum of b, our column B here, that function here for our total cost here in C, all we would do is take, for example, looking at our 2 units here, well, we had 100 hours to start with, add 80 hours to it for our second units here to produce, that's going to give us 180. And then moving down to our 3 units here, we'd add 70 to that 180. We're going to get down to 250, and so forth. So that's how this calculator works here. So that's for our total cost here. And this is really key when we're dealing with these two different models. And then for our cumulative average cost, or on a per unit basis, with this incremental model, you're just going to take whatever your cumulative total cost is for each of your units here, you divide it by the number of units. So let's look at column 2 here. So our total C8 here, let's look at C6 here. So we'd have 180 here for our total cumulative, say, hours in this in this case here, divided by 2 units here, that's going to give us 90 here. And then if we move down to the next one, all you do is take for C7 here, 250 divided by 3 units, the output, that's going to give you 83.4. So that's what with our incremental model here, that's how you determine your cumulative average per hour on a unit cost here per hour. Okay, so you can see the difference here between our two different models here. With the cumulative model, we had for our cumulative total cost here, whatever units we were looking at here, we take it times our unit cost function here, that to get A times B here. A units times B, our function on our unit cost on a per unit basis here. And then for our and then the individual unit time was just the difference moving the difference between your amounts here, looking at your different units for your cumulative total amount. So you'd have C6 minus C5 here. That would be like 60 here, what we went through that, and then C7 versus C6 and on and so forth. And then compare that to our incremental model here. For our cumulative total cost here, instead of A times B, or A times our function B here, column B, all we're doing is summing B here to make that distinction. And then our unit time was just whatever we had for our cumulative total divided by the number of units here. C6 versus divided by A6 here, C7 divided by A7, and so forth. So you see the difference between the two. Okay, so that's for our Excel calculator. Now let's go up and let's actually look at our curve here. So this is our actual laying out those two different models here on our learning or experience curve here. So what I've done here, this is just based on our average or unit time here. So we start out with 100 here, and with our learning model we're going to have actually 3 different curves I'm dealing with here. But our average time is decreasing here as we increase the number of units that were produced. That was based on our Excel function here, X number of units produced across here. That's our learning experience. So we gain experience here, or we increase our learning experience with the number of the units we produced here. And then along for our learning proficiency here, we actually become more proficient here with these learning curves as we increase our number of units that we produce. That reduces our average time here and actually increases our learning proficiency. Okay, so looking at our unit time here, that was our average unit time here. For our incremental unit time model, I'm showing that is our green line here, and let's just go through that here. So that was based on, it would be y equals a, that was the cost of the first unit here, raised, and this is k here. It's not based on the number of units we're producing. Well, it is based on the number of units we're producing, but it's you'd have to go back and look at calculating. It's a big calculation to determine your k here. It's based on midpoints of units on the curve here and so forth. But anyway, it's y, a, to make a point here, k, some factor here, raised to the exponent b here, our learning right here. Okay, and again, a here, that really on our Excel function here, that was just taking our C8, whatever would be our cumulative total cost, divided by A8. That was the number of units for that, for whatever that was on that. A8 was 4 units here. So you're just taking your total cumulative cost here and divide it by the number of units. So that's for our incremental unit time here. And in this case, we'll make the comparison with numbers. We'll make them, so you can see the 66 here for, I don't know, we had 8 units produced or something like that. 56 here for 16 units produced, something on that order here. Okay, so you can see our incremental unit time here. We're not reducing our average time as much with the incremental unit time. So that's the only point we want to make when we want to relate it to our Excel graph here. And then this red line I'm showing here, that's going to be our unit cost, and that's really that f of x function here, y equals a, the cost of the first unit, times whatever units we're producing, raised to the learning rate exponent here. Okay, so that again was on our Excel spreadsheet. That was our b column. That was that f of x column. So this f of x, or this function here, we're using it really for comparing it to both the incremental unit time and then the cumulative average unit time here. Now the argument can be made here with this cumulative average time, it's really using this our f of x function here when you're determining your total cost. But just comparing it on a per unit basis here based on that calculator we had here. First off, let's just understand our unit cost here. F of x, that equals y here times a times x raised to the exponent of b here. And that's the function we're calculating here on our Excel graph. That was that b column. Now for our cumulative average time here, that was really our Excel spreadsheet. That was our column. It was a C6, whatever we have here for our cumulative total, less the previous cumulative total here, C5. So that's making that relationship here on our Excel spreadsheet here. So our cumulative average time on a per unit basis here is really the lowest. That's our B. That's that B showing here. So you can see using a cumulative average time formula here, that we come up with our best learning, or we're most proficient using the cumulative average time. And just looking at our numbers here, cumulative average time on a per unit basis at an output here of 8, we were sitting at 35 hours versus, you can see the incremental time, we're way up here at 66 hours. So we haven't, using our incremental unit time, we're not very proficient using with that, making that comparison here. And then based on our unit cost here, that was 51. 66 here, 51 here for our unit cost, and then our cumulative average unit cost was down to 35, just to make that comparison. And then if you go back and you look at an output of 16 here, for our incremental unit time, we're sitting at 56, and then for that f of x function, we're sitting at 40, and then we go down to 29. So you can see here, with this learning curve here, if you're going to use the incremental unit time, does not improve our decrease our average time on a per unit basis as good here as the cumulative average time here. Okay, so that's the only comparison we want to make here. And then we're going to look here at this C here, just to make a point here, this Excel C6 and C8, that was that cumulative, really our total time, x times y equals a x raised to the 1 plus b, learning right here. And for that was our C column here, and that was based on our cumulative average time here. But the incremental time, instead of an x rate, or x here in the formula, it's k here. We still have x, the number of units, times whatever the cost or hours are for those units, equals a, the cost of the first unit here, times for the incremental time, you're going to have that k factor in here instead of x. X is used for the cumulative average time based on really the number of units produced here, raised to 1 plus b, the learning right here. But with the cumulative average time, you got to put that k in here. Okay, so that's for our average unit time here. Now let's go down and let's look at our total time here. Okay, really we only have two curves here. I'm showing green here. That's our incremental unit time here. And that was xy equals a here times k. That was that function, or that special. We have to calculate that here for our incremental unit time. It's not based on x. Then raise 1 to the 1 plus b here. Okay, so a here on our Excel spreadsheet here, on the Excel spreadsheet, it's just the sum of b here. And remember, b was that function that we're looking at here. So you can see it. That's for our incremental unit time here, shown in green. And then this cumulative average time here. Really, when we look at the cumulative average time, that's based on that function, x times whatever function, that function we had here in column B here. And that's really looking at x times y here equals a, the cost of the first unit, times x, whatever units we're producing here, raised to the 1 plus b here. So if we were looking at this with that 20% learning right here, our B learning rate here was minus 0.322. So if you add that 1 plus the negative 1.322 here, you're going to come up with 0.678 here. So that's for our cumulative average time here. That's our red time here. Again, and that was that x times y here times 100. That was the cost of the first unit here, times x, whatever units we're producing, raised to the exponent here of 1 plus b, which is 0.678. Okay, so nonetheless here, when we're looking at the incremental unit time, of course we had our average unit time didn't decrease as fast as our cumulative average model. So when you're looking at the total cost here, obviously you're going to have greater total costs here, or total hours here. I'm showing total hours here. I've neglected to say it, is on our y-axis here, and that's x times y here. And the total hours are increasing here on our graph here, whereas when our learning proficiency is going down, as we're getting better here, we're increasing our learning proficiency, but as our total hours go up. But it's really just a function of taking x times a number of units here times whatever our function was here. Okay, so let's just look at for our cumulative average time, and then along our x-axis, I'm just showing the x, the number of units produced here, and that's increasing, and then our learning experience is increasing as we produce the number of units, or we increase the number of units produced here. So you can just by comparison purposes, you can see that incremental unit time here at 8 units produced for the cumulative average, looking at 409, incremental unit time 534. So you can see there's a substantial difference here, just as it was for our average unit time here. So our total unit time, here on the incremental model is obviously going to be greater here than our cumulative average model. And if you get up to 16 units produced here, you can see you got for our cumulative average here 655 hours versus 892 here for the incremental unit time. So you can see quite a difference between the two. So it does make a difference if you're using the incremental unit time learning model versus the cumulative average learning time model here. Okay, so this is for our total hours or total time here required. Okay, so now let's go back and let's look at some log-log graphs here. Again, we're going to look at a log-log plot. These are a little easier to look at here, and we're just look at our unit time. That was that first graph we looked at here, and laying out here on a log-log graph or log-log scale. Same situation here. Average time is going down here. Learning proficiency is increasing as our average time is going down. But we got a log scale here, and we have a log scale here. So the point is this: for this red line here, that was that function that f of x function here. And when you're looking at it in a log-log graph here, really what you're looking at, you got a straight line coming down here. That was that it really is represented by y here equals a times x raised to the exponent of b. But we're interested in the slope here, and that's really for that function that we're looking at here. B equals, again, that log base 2 or whatever our learning rate was, 0.8 or 80%, 0.8. That equals a minus 0.3219 here. Decreasing, moving down here. Now, we laid out, just looking at that graph here, that unit time graph here, looking at the incremental unit time, which it didn't decrease as fast as the cumulative average time. And it also has a little bit of a curve in here. It has a little bit of a curve in here based on that learning right here, that incremental unit time. And that was a special calculation that we had to make here. But nonetheless, the incremental unit time here isn't decreasing as fast as the cumulative average time. The cumulative average, I'm showing that in blue here. Again, it has a little bit of a curve here in the graph, or a little kink right here in the graph. All right, but nonetheless, the steepness of the slope here. I don't have the slope shown here for exactly what they are. I'm just making a comparison here to that function we have here, that slope, negative 0.3219. Obviously, the slope here in incremental unit time isn't as great as it. It is a negative rate here, but it isn't as great. And then the cumulative average time, we're increasing our learning rate at a better rate here than the incremental unit time. So the steepness of the slope here equals, or the more steep it is, the more progress we're having. We're having more rapid progress here in our learning rate, and we're having a lower cost here. Okay, so that's just looking at it in terms of laying it out on a log-log scale for the number of units produced versus our average time here per unit here. Okay, All right, so you really want to, the better curve here is as far as our learning rate, because we're learning at a faster rate here, is using the cumulative average model. And if you lay it out on a log-log graph, it's kind of easy to look at here and to make the comparison between the two here. So that's what you want to look at. And then finally, let's go down here. Just looking at total time here, again, making the incremental unit time because we didn't decrease as fast as we did with the cumulative average time here. You're going to have a greater total time in hours. Again, I'm looking at a log-log graph here. This is the total time in hours here. So it's increasing here as our learning proficiency increases. It's really looking at our learning proficiency. It increases as we produce more units here across our x-axis. Again, it's a log-log scale. And just for comparison purposes, again, we're looking at the slope here. So really you want to look at the slopes here. And these are pretty straight slopes here, not a lot. So really what we're looking at here, for either of these models here, what you're looking at is 1 minus b here, or b was that learning rate exponent. We have 1 minus log base 2 here times whatever the learning rate is. In this case, it was 0.80 here, and that equal to 0.678 here slope. And that was 1 plus b. Remember, b was that minus 322 here, so you add that to it. 1 plus the minus 322, you're going to come up with 0.678. So anyway, this is a positive slope here. This is an increasing slope because that's looking at our total time in hours here. But nonetheless, you want to make the comparison here. Our incremental unit time has a steeper slope here, and that's really telling us that it's taking more our total time here using the incremental unit time model versus the cumulative model I'm just showing as our red line here. It has a lesser slope. That means we're having more progress here, progress here. It equals a lower cost. So you just have to understand when you're looking at these different log-log graphs, what you looking at the slope. So the comparison is a good comparison here looking at a log graph. So total time, you're going to have an increasing amount of time here, so that's going to give you a positive slope here. And I'm just looking at 0.678 here based on that 80% learning rate. Okay, so that'll pretty much summarize our topic here. Just remember, you have to make the comparison here with the incremental unit time versus the cumulative average time, and how we laid those out on our different our Excel spreadsheet or Excel calculator, and then how we related them to the graph here. And I just showed this log-log graph here that when you lay it out in a log-log form here, you can make an easy comparison between the two, just looking at comparing slopes here. You can also determine your times here on a log-log scale in each case, but it's nice to look at it and just understand what the difference is between these two different models in this case. And of course, if we use the idea is if you use different learning rates, say if you had a 90% learning rate versus a 10% improvement rate, you're going to get or 70%, 70-30, so forth, you're going to get different graphs here. So that's the idea as well here. Okay, so we just looked at that 80% learning rate versus a 20% improvement rate. But whatever your learning curve is based on, you'd have to lay them out on these graphs and set up determine your different quantities accordingly. Okay, so that'll summarize our discussion.